Hello boys and girls. This video is a kind of follow-up video to a video that I did like 2 months ago, where I discussed the deployment of the first Musify smart contract. That was a video where I deployed basically an application that had a user reward model for a kind of social network implemented, and back then we had it implemented in a way that when you have a user action, like Musify is a platform where people can upload songs and people can vote on songs and contribute in various ways, and we would reward that in cryptocurrency, in the IMU token. And what we did there was a very basic implementation where for each reward the user would get some IMU, and after, I think in the contract it was like after 3 contributions the user would always step up a level, and if the user reached a certain level then he get a multiple of the reward with each output. So as an example, the user would upvote, would get some reward, upvote, get some reward, upvote, get some reward, and then after the 3rd upvote he would be on level 3, and after the level 3 he would just get twice as much as a reward. And then when the user would do 10 upvotes or whatever action like song upload and participation in the platform, then he would get to level 10, and from level 10 on he would get 5 times as much. And that was of course a very coarse kind of implementation, because then user would get over a certain level and they would get more and more, and given that you don't want an inflation with your token model, this would easily get out of hand, and so to implement it on a real website you have to think a little bit more carefully. And 2 weeks ago or so I came back to that problem and I extended it a little bit and tried to implement some features. For example, counter the fact that you have these big jumps and you wouldn't know when to place the jumps, because of course when we start the platform then it's not clear how exactly the user base will grow and how big the output shall be, and also what the dollar worth of IMU token will be. And so you have to be cautious to not hard code in a smart contract situation where things get out of hand. And so today I want to discuss first steps or first proposals to get to a little bit more refined model, and on the one hand explain to the developers and to future audience the ideas, and also get some feedbacks and point out where some change could be made. Okay, so what we already had in the first contract was the idea that we don't only have the IMU token, but we also have the user level, and this user level can be also a sort of token on the blockchain, or just handled in the backend of the website. And so every user would start with a level. We can set it at 0, or we can start it at some random point. This all depends on how you're going to use that level, where you want to start. But you have to start somewhere. You want to treat all new people who sign up to the site equally, so you start at the same point, and let's say that's 0. And then the idea would be that whenever the user does an action, let's call it action A, then you would go from the level L, whatever it is at the moment, to a higher level. So level L plus, and then some delta for difference level, according to the action. And the natural thing to do here is to set the value of the actions in relation to each other. For example, if you have the platform where people shall upload a song, then that would be very valuable. And also valuable, but maybe a little bit less effort, is to write a review of that song, simpler would be to do the upvote that I talked about. So naturally you would want to adjust the delta L, the level up, according to that. I actually have written a small Python reference implementation for these presented ideas, and to refer back to that, what I did there was basically give us in the back end the option to value these kind of contributions on a scale from 1 to 100, and I assigned the level raise of 5 for an upvote and a level raise of 60 for an upload of a song. So in that sense, an upload of a song would be, for example, 12 times as valuable. But these are all up to change, and if you have it in a smart contract, then you could also make it so that the people who have access to that would send it, or you actually hard code it if you're very sure of what you do in advance, or you just read it as backend. And if you know some Python, the way I implemented it there was just to create a configuration class, and there you have these kind of settings and also other settings that we will present in the video, and you would just pass this as an argument, this configuration, to the model, and so you could update it if you want and restart it. And but just for simplicity's sake, let's say for the action of upvote, the user level raises by 5, right? And then after 3 actions, of course, each action gives an additive level up. So after 3 actions, the level would, like if you started at 0, then the action would be at the sum of these 3 level ups. Let's say the user really, is not a musician, but just a consumer of music, and he upvotes 3 songs he likes. Then he would get 5, 5, and 5, so 15 points, and he would be at level 15. And I also want to mention that what I have seen is customary is that the rating that the user would see on the platform is usually not necessarily the level, as it linearly grows, like step by step, on the backend side of the platform, but actually on the interface the user sees the logarithmic value of that. So if the for example, if you have the logarithm of 10, then if the user is at level number 10, then he would see only rank 1, and then if he gets to level 100, he would be at level 2, and if he gets to level 1000, he would get level 3, and so on. So if he was at level 20, which is between 10 and 100, then he would be at rank 1.2 or something like that. One of the ideas behind that is that this means if the level in the background actually grows linearly, the user see not a linear leveling of his rank or of his reputation, or however you want to call it, but it's actually harder to get to the next, because from the first to the second, he gets from 0 to 10, it's more or less easy. From 10 to 100 is harder, from 100 to 1000 is a lot harder, and so on. And you have these systems in for example, World of Warcraft, where at first user level up very quickly, then it gets hard and they want to get to the next level, and it's kind of a gamification aspect to it, that it poses a challenge. And you have the same thing on Steemit, for example. You can look at the Steemit blockchain. If you look at the block explorer, then you see the actual level, which is a different level than the number you see. If you know, Steemit is a kind of social network on the blockchain. And there also you grow, like, it's very hard to grow and grow. And it's, for example, not an accident that on World of Warcraft as well as on Steemit, getting to level 50, 60, 70 is very hard, and that's where it kind of stops, right? So the fact that it kind of ends at 70 is because there the logarithmic challenge for linear increments gets harder. In any case, that was a kind of digression, but my point being, even if you do work with L in the background, in the backend, doesn't mean that that's necessarily what we want to show the user. But that's what we calculate here in any case. Okay, and so if you want to do the leveling up, the value of the leveling up depending on the action, if one action is less or more valuable than the other, you might also want to reward differently according to that. So the first kind of a naive model without the bonus feature that I will discuss in the second half of this video is that you pay the user, he does an action, and the action is, let's say, according to a level up of 5, and you pay the user with the token, IMU token, 5 times, and then some proportionality factor, which I introduce here, which I call market factor, because with this market factor you kind of gauge a sensible value in terms of, for example, fiat dollar value, like to kind of get a multiplication factor for this number 5 that it makes sense, right? Because when we do an ICO and there are, like, I don't know what the number will be, say, but let's say 3 billion token, right? And they are sold at some NEO price, then this NEO price corresponds to the NEO price gives some rough valuation of the whole market capitalization, like the whole value of the totality of the token, and this gives a value to one token. So let's say you tweak it, you tweak the NEO price at ICO in a way that like NEO is, let's say, $100, and you say, for one NEO I give you, I don't know, 10,000 IMU, right? Then you have a correspondence where one IMU is valued according to 1 cent, for example, right? Because 10,000 times 1 cent is this $100 that you spend with the NEO. Okay, so you cannot, like, be naive and say, well, the level up is 5, so I reward you with 5 IMU, because it might not make sense in terms of dollars. So there will be a proportionality factor, and I'm just inventing numbers now, obviously, but let's say an upvote is, I don't know, 10 cents, right? Then you would have to set M to 2, to the value of 2. If IMU is 1 cent and this action is 10 cent worth, and the level up is 5, then you would set this M to number 2, and then this action actually corresponds to the right reward, right? And then if MU were to, it moons after ICO, or it breaks down because the whole market crashes, what you don't want is to make the reward model totally unsensible, right? You don't want that suddenly an upvote of the user costs the IMU platform, which just has a finite reserve in a model without an inflation. You don't want the upvote to be worth $5, and at the same time you don't want the upvote to be worth, I don't know, 0.00001 cent, because then there's no incentive for the user, right? So you have this tweaking factor there. Okay, so this, up until now, this model is even more simple than what was implemented on the smart contract for our first DApp contract. And I want to add another thing here though. For the implementation, it's also a question of how often do you actually want to interact with the blockchain, right? So for the first smart contract, we had a middleware set up, like a program which lets the server that hosts the Amusify platform communicate with the blockchain, and you would, upon registration of some user action on the website, on the front end, you would have that signal to the back end, and the back end over the middleware would talk with the blockchain, and there we would do the reward and give out the token. If you have a huge platform with I don't know how many users and they all vote at the same time and so on, then you would not, under some circumstances, want to talk with the blockchain for each operation, right? You could also accumulate actions, right? You say, okay, you wait for 1 day or I don't know, 3 days, 1 week, 1 month, and say, oh, the user in this time, he voted, I don't know, 20 times, so he has a level up of 5 times 20, so a level up of 100, and then only after a week I will actually compute here what is actually the reward I should pay you, right? And then do the payout. So if you have the whole logic here on the back end, then you can also do this addition on the back end and accumulate and record what the user should get. And then only do it in intervals. And so it was one goal of the implementation, and that's also in the Python script, which I will post in the comments, and YouTube section bar thingy, was that you can play around and get some freedom, and then we can also discuss here what makes sense, what doesn't make sense, and what part should go to the blockchain, to what extent this is actually valuable, to what extent can we decentralize it, to what extent does it make sense, and so on. 1 second. Okay. Okay, so that's one thing. This simple multiplication of the value of the action times some market factor that can be adjusted to a volatile market, and an idea of me, or this is all up to discussion at this point, is to run it for 1, 2, 3 months and look at the kind of average user or the user that provides good content, that shares on the social network, and this does the user par excellence, and see what does a user of this kind actually do in terms of level ups, and then evaluate it to give it a sensible correspondence in fiat. So what is this kind of action worth? Like, how can we properly reward them to not get too short or not bankrupt the musical platform, and then see, okay, this is a fiat valuation of this level up that makes sense, and then the other users, whether they do less and get less level up, or whether they are more active and get more level up, they are fairly paid out in reference to this good average user, right? And so I said fairly, and the question is, how can we tweak that system a little further and make use of the level as we did in the first smart contract, but in a more sensible way than just saying, you get up now you get twice as much or three times as much, and so on. Okay, and so this is the second part here of this slide. Okay, so firstly, I take this simple equation, right, and I rewrite it a little bit in a very simple way that doesn't actually change the formula. So what I do here is I introduce next to the market factor m 2 other parameters, and that would be b, which is the maximal bonus, and then h, which we'll later see is the level at which half, that's why h, half of the maximal bonus is reached. You will see that in a second, but the point is that if I write this expression like that, then you have here h over h, that is cancels out, this is 1, then you have 1 minus 1, so that is 0. So that whole expression is actually 1 plus b times 0, that is actually 1. So this expression is actually 1 in that case. So this is actually naive to write this down. This doesn't really do anything. I just want to extend it like this. So here you see this is just the same formula with 1 written in a complicated way. Okay, and so now what I actually want to do now is not take this formula, but instead add here, instead of h, I write h plus L, where L is the user level. And so when the user just joined and has user level 0, then this expression, then is 0, and then you have the same situation as before, h over h is 1, and this doesn't make any difference. Then the reward is just the basic reward. But, so we see when we pay out, and pay out always means the user got a level up, then this L will slowly but steadily grow up, right? The L will go up. And what will then happen is, as L goes up, I've written this down here, so this F is this factor here. As L goes up, this is the numerator, the denominator will grow, right? And will start at h, and then it will h plus 5, h plus 10, h plus 15, and so on. It will grow away, and the denominator will grow bigger than the numerator. So this expression here will be some number divided by a number that's slightly bigger, right? So this will start at 1, h divided by h is 1, and then it will go down. So it will go down to 0.9 something, and 0.999, 0.997, and so on. And as the user level grows, this number goes slowly to 0. And so 1 minus this number, right? This goes slowly then to 1, because at first this is 1 and this is all 0, but if L grows and L becomes bigger, then this gets smaller, which means 1 minus this number gets larger, right? And if L goes to infinity, is huge, then you have h divided by infinity, and this becomes 1. So this is a function actually that starts at 1, and then as L grows, this becomes 0, and this expression, this whole expression, these round brackets, becomes 1, and you see then that this f grows from 1, where we started, to 1 plus b, very slowly but steadily, grows to 1 plus b. And so what we can do is actually not just reward by m times delta L, but so one feature of the PDF is this logarithmic difficulty, and so if you plugged it in, you get to this kind of inverse situation. And if we cannot really see how the user base will grow from the start, but if we then see that it's too easy or too hard to get to a particular kind of bonus, then we can shift this h back and make it harder. And of course, at the beginning there will be some months in tweaking where you have to kind of find out how this plays out. But if you do it this way, then the bonus here depends only on the level. And so if you tune it in a way that the average user gets a fair payout, then the other rewards are also fair in respect to that. So all users are treated equal, right? Equally good or equally bad. But in my opinion, it's better than a Steemit system, which contains 4 private keys and 5 different coins, and Steam dollar and reputation and so on. And then in the end it explodes and doesn't work anyway, because you have this runaway effect. So ideally I would like to see a platform where you don't have this winner takes it all scenario, and I was trying kind of to go into this direction with the model, right? The platform will, to prevent bots and these kind of activities, can implement captures, and we have also discussed in the Discord to, for example, have a kind of monitoring and profiling of user activity, in that if you know, you can make it arbitrarily complicated, of course, and if you can judge the content, for example, take into account how user shares of content is voted by others, how valuable it is, then you can also adjust the delta L's, the level ups, depending on that. You can start at the basic level up, let's say 5 for a user upvote, and I don't know, 30 for a review or album review or whatever it is, and then you can give a deviation of that by weighting with some logic that depends on the rating of the quality, for example, of the review, that you don't want all reviews to count the same, and kind of let the history and the past activity and prospective future activity play into that. But these are all the things that you also can do in the backend,